Welcome to this video on the hardest questions on P1 from the year 2023. Now, if you're new or long-time viewer but unsubscribed, please consider subscribing. If you enjoyed the video, like the video. And if you find my content has helped you and you wish to help me out a little bit, just please consider joining as a member. Even if it's only for a month, every little bit helps. Right, let's get into the questions. Now, this paper was answered quite well. Questions 4, 5, 9 and 11 were the ones the examiner deemed most challenging. I think question 4 was answered pretty well by a lot of people, but with a lot of candidates just getting 3 out of the 4 marks. So I'm going to show you it today now so you can get the full 4 marks if a question like this comes up. So immediately jumping out at me here is has no real roots. So that is b squared minus 4ac being less than 0. Okay, so discriminant. Now let's work out or substitute our values in. So already in ax squared plus bx plus c equals 0 for us. So 6k squared minus 4 times k times 5 is less than 0. So 36k squared minus 20k is less than 0. Now I can see where I think a few people would have gone wrong on this, and I'm going to do it now in black. Okay, so 36k squared being less than 20k dividing by k, and then dividing by 36. So that, I suspect, would have been, and that's like 5 over 9. So that's what I would suspect a lot of candidates did to then only get the 3 marks out of the 4. Okay, which is obviously wrong, because you shouldn't be dividing by one of your unknowns. What you've got to do is factorize. So take k outside, so then we've got 36k minus 20 is less than 0. So critical values, I like to do this to the side, is k equals 0 or 36k minus 20 equals 0. So that's k is equal to 20 over 36 or 5 over 9. And it's a squared, so it's a quadratic. Okay, so it's going to look like this. Yeah, oh, it's very badly drawn. Let me redraw. It was only a sketch, but so this is my 5/9 and this is my 0 for these two values there. Now we want less than 0. So we want when this curve is below the x-axis. So we want to the right of these values and to the left of these values. So now I can go ahead and state it. Now it's one region, that central one, so I can put it as one inequality. So it's less than 5/9 greater than 0. And that's how I get the full marks. But obviously, like if I'd taken the step I showed earlier, dividing by k, I lose one of the solutions and therefore lose a mark. And then the final step again, you know, sometimes it's just not set out right. People get the 2 values and then don't know whether they want outside regions or inside regions. Okay, so just set it out. Critical values are these 2 points, and then your sketch is based on this. Okay, sketch is based on this, and then this bit will tell you whether you want above or below. Okay, this one's below, so this is the region I want. If it was above, I'd have this region and this region. Okay, quite straightforward, but there's just a couple of lessons for people to learn there. Now, question 5. I've seen this type of question on a few of the past papers, and it's getting the same kind of responses. Like many candidates attempting this question, but a significant number either did not attempt it, or they couldn't do part A. Some had picked up 1 mark then on part B. Okay, it's quite a straightforward question. Okay, but it's just substituting that P. So let's make a start on this. So here I've got P is equal to 3x, but this is obviously 9x. Okay, so I want to change it into 3x. So 3 times, now 9 is 3 squared to the power x, plus, now 3, now x plus 2, so when I've got powers, like 3 squared times 3 to the power 5, I add the powers. Yeah, that's 3 to the power 7, isn't it? 2 plus 5. Now with this one, x plus 2, I've got to go from this step backwards. So I'm separating them out. So it's 3 to the power x times 3 to the power 2. That equals, now 1 is 3 to the power 0 plus 3 to the power x. Now minus 1 is divided, isn't it? So 3 to the power 1. So that's what I've done now. Just separated everything out. The powers of 3 to the power x and others into just 3 to the power something. Okay, now I can go ahead and substitute P in. Now before I do this here, this is 3 to the power 2x because you multiply the powers, but equally I could write this as 3 to the power x squared. Okay, so that is just now 3p squared plus, now 3 squared is 9p equals, I could just leave the 3 to the power, I could just leave that as 1, making it more complicated than it is. So p over 3. So that's what we've got. So now I'm going to take everything, before taking it to the other side, what I'm trying to get is this. It's got no fractions in it, so I'll multiply through by 3. Okay, but that was the hard step, the step taking out the 3 to the power x's. Hopefully everyone followed that okay. And I'll just rewrite that one over here. 3 to the power 2x is the same as 3 to the power x squared. Okay, so just to reiterate that. Now multiplying everything through by 3, we get 9p squared plus 27p equals 3 plus p. 9p squared plus 26p minus 3 equals 0. And that is part A done. Okay, and that's something you want to learn. Okay, got to learn how to deal with these indices. I've seen this question on quite a few papers now. It's obviously a non-calculator question, as this lines up the top mean it's a non-calculator question. Now part B is hence solve. So hence solve this. This is this, but this is equal to this. So we've got to solve this equation. So 9p squared plus 26p minus 3 equals 0. So factorize it. So 9 times 3 will give me 27, and 1 will then give me the 26 when I take it away. So this is going to be positive, this is going to be negative. So p equals 1/9, p equals minus 3. And then swapping p back for the 3 to the power x here. 3 to the power x equals 1/9. 3 to the power x equals minus 3. So this is no solution, because 3 to the power anything is not going to turn it into a negative. This one, 3 to the power x, is, well, it's 9 is 3 squared. And then taking it from the bottom to the top will give you a negative power. So 3 to the minus 2, so x equals negative 2 there. All in all, quite a straightforward question. In the beginning, I would suggest this type of thing. This 3 to the power 0 wasn't needed as a 3 to the power 0, it can stay as 1. But converting there before jumping in with the p's, okay, just to make sure you get your full marks there. But otherwise, I think fairly straightforward, okay, but you have to be careful. And again, solving for p, then replace the p by the 3 to the power x. I think you could probably have jumped from this line to the end, so you could have even used your calculator there if you didn't realise this step. But this step would guarantee your full marks. Okay, question 9. So, relatively small number of candidates achieved full marks, less than 5%, and more than half of all candidates scored 0 marks, with approximately 10% not attempting this question. The most common score other than 0 was 1 mark, with a small few scoring 2, 3 or 4 marks. Okay, so it's only worth 4 marks, so if you didn't, get it, it's not the end of the world. But if this type of question comes up again, let's make sure we can get it. So let's have a little look. Okay, so the period for tan. So tan graph goes between pi by 2 and minus pi by 2, that central one where you start off. So the period of that is just going to be pi. Okay, 180 degrees. Now, part B, write down the number of roots of the equation tan x equals pi plus 2x in the interval. Right. So this is pi by 2, like an asymptote in between these. So this is going to be pi 0 minus pi by 2 minus pi. So that's my, axes effectively done. So we've got tan graph, which is there, and then pi plus 2x. So this straight line is pi x. Pi plus 2x is going to be moving this graph 2 to the left. So moving it 2 to the left is going to be something like that. Okay, because minus pi over 2 is what, 1.5. Minus pi is minus 3. So that's 1.5 over 3. So it's going to be somewhere there. Okay, so it's going to cross 1, 2, and then this one, 3. So it's going to cross in 3 places for part 1. Now for part 2, we've got, where's this line cross the x, cross the tan graph between minus 2 pi and 2 pi. Right, so it's going to cross, if I look to the right, it's going to cross 1. This one goes to pi here, then it's going to go up. So it's 2. And then, yeah, it's 2 on each side. So we'll cross this one once, and then this one, it'll cross once up there, and then we'll get this at the bottom, so it won't cross. And again on the left hand side it crosses this one once, then this one once, and then we'll have this one at the top, so it won't cross. So 1, 2, 3, 4, and then through the center 5. So this crosses in 5 places. And then part 3, minus 100 to 100. So if we look at the pattern, even on this one between minus pi and pi, it crosses in 3 places, doesn't it? So 3 places between minus pi and pi, 5 places between minus 2 pi and 2 pi. So if you think about it, just taking the 1 out for the centre, it will cross in 2 places between pi and minus pi, 4 places between 2 pi, so it's going to be 201. Okay, and there's the full 4 marks. Just think it through logically. The final question on this particular paper again was one of the more challenging ones, where people did pick up some marks, but not enough scored full marks on this one. Okay, so let's have a little look at it. So part A says find an equation to the normal to C at P, but the tangent to C at P is this equation. So that means the gradient of normal is going to be minus 1/3. Now P has x coordinate 4. So using the tangent where x equals 4, 4 is 12, 16. So P is 4, 16. So now we can find the equation of the normal. So y minus y1 equals mx minus x1 is what we're doing. So y minus 16 equals minus 1/3 x minus 4. Okay, that's actually enough to get the 2 marks there. But again, you can go and sort it out, but that is actually enough. 3y minus 48 equals minus x plus 4, x plus 3y minus 52 equals 0. Now part B is find f of x, writing your answer in the simplest form. So first we're doing f dash of x, so we're going to integrate this. So 4x, first of all, let me rewrite this. 4x plus x to the minus a half. So 4x squared over 2 plus x to the half over a half plus c. So 2x squared plus 2x to the half plus c. Now we know the point P lies on C, so that's 4, x is 4, so 2 lots of 4 squared plus 2 lots of 4 rooted. So 1632 plus 4 plus c, and the integral, sorry, this is the like dy by dx, isn't it? Differentiation. So that has the gradient of the tangent, and that's the key step in this bit. So it's going to have a gradient of 3. So this is equal to 3 on the other side, and that's the key step in this bit. So c equals minus 33. You have to work that out first before going on to the final integration. So we got 2x squared plus 2x to the half minus 33. Okay, and this key step here is, well, harder to spot, especially towards the end of your time when you're a little bit tired. But anyway, right, after that then it should be quite straightforward. 4x, sorry, not 4x. Right, 2x cubed over 3 plus 2x to the 3 over 2 over 3 over 2 minus 33x plus k. So it's 2x cubed over 3 plus 4x to the 3 over 2 over 3 minus 33x plus k. So that is now my next step. And my next step is the point P. So when x is 4, y is 16. So for my first step, when x equals 4, dy by dx equals 3. And then final step, when x equals 4, y equals 16. So 16 equals 2 times 4 cubed over 3 plus 4 times 4 to the 3 over 2 over 3 minus 33 times 4 plus k. And that gives me that k is 284 over 3. So my final answer, I'll write it in black here so you can see it. 2x cubed over 3 plus 4x to the 3 over 2 over 3 minus 33x plus 284 over 3. And that finishes that paper. Okay, we're moving on to the June 23 questions. And this is the first one. We're going to start with question 3. Now, part A was generally well done by most people, but surprisingly part B wasn't. Lots of people didn't sketch part B, or they sketched it and they didn't label it, and generally weren't able to link part A and part B together. So let's make a start. It's quite an easy question. Okay, completing the square. So we start off with 3x x squared plus 12x plus 13. And then we've got to take the 3 outside. So 3 outside, brackets x squared plus 4x, brackets plus 13. Remember, I've talked about this before. When you've got a coefficient of x squared, take it out of the x squared and the x term and put in square brackets and leave then everything outside it. So then when I move on to the next line, I set my next line up like that. Everything outside the square brackets stay outside the square brackets. And I just focus on then inside the square bracket. So that's where we complete the square. X plus 2 squared, because it's just half of this value, minus, and then 2 squared is 4, and there we have it. Now expand my brackets, so it's 3 times x plus 2 squared minus 3 times 4, which is 12, plus 13. And then we got 3x plus 2 squared plus 1. So that's what I've got for part A, completing the square, where A is 3, you don't need to do this bit, B is 2, and C is 1. Now, part B, hence or otherwise. Oh, it doesn't say otherwise, hence. Hence always means use the previous part in the question. It means it's going to make it easier for you. So that graph is going to be the same as the 3x plus 2 squared plus 1. So sketch your x and your y axes. You can obviously use a ruler here. Now, in terms of where it's going to cross, we know it's going to cross at 13. Yeah, because that's the y-intercept. And then we'll look at the point. So the minimum point, I'll do this in black. It's a positive x squared curve. So it's going to look like this, because it's an x squared curve. Minimum point, well, how do I get the minimum? It's going to be when this bracket is 0. So that's going to be when x is minus 2. And when this bracket is 0, this is all going to be 0, so I'm just going to be left with 1. So y is 1. So I got my shape, I got my minimum, and my y-intercept is 13. Okay, and then I just draw it. So I go across 2, 1, something like that. Okay, and then I just got to draw my shape. Now on this side here it's 13, and this bottom you can put in the coordinates minus 2, 1, or you can write them on the axes. So you could have, and I'll do this in black as an alternative, put minus 2 and 1 there on the axes. And of course we should put 0 in. Okay, that's what we needed. So to get the full marks here, U shape, and the U shape has to come down into this second quadrant. 13 on the y-axis, or 0, 13 as a coordinate. And then the minimum point, the vertex at minus 2, 1. Okay, so easy marks all around here. Just, make sure you're learning these, because these are your easy marks, and you don't want to be dropping your easy marks in any assessment. You want to make sure you're gaining all the easy marks, so that then you give yourself the best chance of getting a high UMS. Now, next question to look at is question 6. Now, according to the examiner, the marks were, most candidates got marks in part B. That was well answered. But part A less so, and part C rarely. Okay, so again, it's small marks in this question, but they all count, and being one of the middle kind of questions, it should be, relatively accessible to everyone. So, 2 ways of approaching this. It's expanding a double brackets. So you could write this as r minus 1 over r brackets r minus 1 over r. Expand this way, your firsts, your outsides, your insides, your lasts. Okay, alternatively you can do it straight from the brackets. So with a squared bracket, square the first term, so that's r squared. Sorry, let me just write the question out. So square the first term, r squared. Twice the product, so times these two together, so r times by minus 1 over r. So r times minus 1 over r times by 2, twice the product, and then square the last term. Minus 1 over r times minus 1 over r is plus 1 over r squared. Okay, I wrote this out like here, but normally I would do this in my head. So this is r squared. R times 1 over r is 1. So r times minus 1 over r is minus 1. Times by 2 is minus 2. So it's minus 2 plus 1 over r squared. So that's part A. Now part B, like I said, was generally well done. So multiplying top and bottom by 3 minus 2 root 2. So that gives you 3 minus 2 root 2 on the top, because that's just times by 1. 3 times 3 is 9. 3 times minus 2 root 2 and 3 times plus root 2 will cancel out. And 2 root 2 times minus 2 root 2 is going to be a minus. And 2 times 2 is 4. And root 2 times root 2 is 2. And 4 times 2 is 8. So it's going to be over 8. So that's 3 minus 2 root 2 over 1, which is just 3 minus 2 root 2. Okay, so that's part B done. Now, part C. Use the results of A and B, or otherwise, to show that. So when we look at it, we've got this minus 1 over this equals 2, which is very similar to this, isn't it? This, in this case, we've got plus this equals 2. But the 1 over the minus is in here, isn't it? R minus 1 over r. So that's going to link to that. If this is r, then r squared is just the 3 plus 2 root 2, which will come out there. So that's what we want to look at. So what we want is, we want to go with this 3 plus 2 root 2 minus 1 over 3 plus 2 root 2. And this is similar to what we've got up here. So if r is this, and then minus 1 over r is minus 1 over this. So what we want to do is we want to square that. Because if we square that, we've got this then, and this equals this. So this is going to be r squared. So if r is the square root of 3 plus 2 root 2, r squared is just going to be 3 plus 2 root 2 minus 2 plus 1 over 3 plus 2 root 2. So I'm just substituting in to here. Okay, now 3 plus 2 root 2, I'll leave the minus 2 there, plus, and then from part B, this is this, isn't it? So that's 3 minus 2 root 2. So now I can see that the 2 root 2 and the minus 2 root 2 will cancel, leaving me with 3 plus 3 is 6, minus 2 is 4. And then square rooting both sides. So taking square root, we get that therefore 3 plus 2 root 2 minus 1 over 3 plus 2 root 2 is equal to 2. And there we have our final answer. And again, I have seen similar questions to this in the past. Okay, fairly easy marks now that you've hopefully seen it and hopefully will remember how to approach it. Now part C can be done a few different ways. This is just the way that I prefer to do it. Next up we have question 7. Now this question mostly scored 0, 1 or 4 marks. Okay. The examiner also notes that many candidates were unable or struggled to find the trapezium area in terms of A, so often then lost the method marks there. So it looks like an interesting question. Let's get into it. So first let's see what we can find. So we're doing part A first. So 10 minus 2x equals 0. So I'm looking this line here and I'm going to find this coordinate. 10 equals the 2x, x equals 5. So this is at x equals 5. So we've got the base now from 0 to 5. Now we can find this coordinate here because it's when y equals 2. So 10 minus 2x equals 2. So 2x equals 8, x equals 4. So this point, this is the coordinates for 2. So there we have 2 points. At the moment we don't know this one here. It's A2. And then this one is 0, 0. But we know the area of R1. So using this, we've got all the coordinates bar A, and we've got the area. So we should be able to use them all to find A. So area of a trapezium is A plus B times H over 2. So the area is 27 over 4. Now A is 4 minus a. The distance along the top here, I'll do it in black, this is 4 minus a, and this distance is 5. Plus 5. Now the height is 2, so times by 2 divided by 2. So now I've got 27 over 4. These 2's will cancel with each other, leaving me 4 minus a plus 5. Okay, or 9 minus a. So a is equal to 9 minus 27 over 4, which is 9 over 4. So that now is a. Now that I've got a, I can go ahead and work out k. So this line here goes through this coordinate. So y equals kx. It crosses the coordinate 9 over 4, 2. So when y is 2, x is 9 over 4, and that's times by k. So that's going to be k is going to be 8 over 9. Okay, so that's how I approach part A. I think that's the most logical. There might be a few other ways. Let me know if you have another way. But that's how I approached part A, and that will give me the full 4 marks there. Now, part B is define the region R2. So it's below this line. So y is less than or equal to 10 minus 2x. It's greater than this line, but this line's dashed. Okay, so this is a is 9 over 4, so it's greater than 9 over 4. So x is greater than 9 over 4. And notice I don't put an equals in on this one. So I've got less than this line, greater than this line. And then we want greater than this line, because it's above it. So y is greater than or equal to 8 over 9x. And then I just double check I've got everything. So right to this line, above this line, below this line, that'll give me the triangle shape there. So that's where I need 3 inequalities, and that's them done. So that's the full 6 marks. Okay, and with talking in the beginning, it took 6 minutes. Okay, really, this is probably a 3 or 4 minute question. So it's where you can gain plenty of time in the exam. So this question was the one that was deemed to be the most challenging for the majority of students. And it's the last question, so in part of that comes down to the timing. So, basically either students ran out of time, so they didn't go much past part A, or simply some students didn't know how to proceed past part A. So in this case, a lot of students obtained the correct equation for line L, or line 1, L1, but that was for many the only mark scored. So let's have a look at this question. It's worth what? 2, 4, 6, 10 marks. So it's a good chunk of the paper here at the end. Okay. So from this information here, we can deduce that this is the coordinates -2 and this is b for the x coordinates, just from the two brackets. So where it's going to cross the x-axis is when this bracket equals 0 or this bracket equals 0. So -2 and b. Now L has a gradient of a half, and you can see that it intersects the negative x-axis. So it intersects at that -2. So it's got a gradient of a half, and it crosses to the point -2, 0. So we can use that to, solve it. It doesn't actually need the y minus y1 equation, but because of the 0. But anyway, so y equals a half x minus 1. No, sorry, that's plus 1 because it's -2. So minus minus. There we have it. So half x plus 1. Almost made a really silly mistake there, didn't I? Now, part 2. Find in terms of b the coordinates of p. So L1 intersects the curve at p, because we don't have L2, do we? No. So L1 intersects the curve at p. So that's -1/4 x plus 2 x minus b equals, now I'll write it as a half x plus 2, just using this part. Just because of that x plus 2 there will enable us to cancel. So we can cancel with the x plus 2, and then multiplying up by -4, we'll have x minus b. -4 times by a half is -2. So x equals b minus 2. Now we need the y coordinate. So y equals, we'll use the half x plus 2 part of the equation. So it's half, if x is b minus 2 plus 2, so those are going to cancel, leave me a half b. So that's what y is. So my coordinates are b minus 2 and a half b for my x and y coordinates of p. Okay, next we need to find an equation for L2. It's perpendicular to L, so the gradient of L2 is, now the first one was a half, so this is going to be -2, and it intersects C at the positive axis, so it intersects C at B, so it's going to cross the coordinates b, 0. So y minus y1 equals x minus x1. So y minus 0 equals -2 x minus b. So y equals -2x plus 2b. Now part C says given that L2 also intersects C at the point P. So for that we need to go with the gradient of L2 is -2, but this time the coordinates b minus 2 and a half b, and create another equation. So y minus y1 equals mx minus x1. So y minus a half b equals -2x plus 2b minus 2. So I didn't really need to sort this out, but I will obviously sort this out. Y minus a half b equals minus 2x plus 2b minus 4. So y equals minus 2x plus 5 over 2b plus 4. Sorry, minus 4. So often I do that little silly mistake, you know, go from minus 4 and then just magically make it a plus 4. I don't know if any of you do that, but you do have to be very careful. Now part D, hence or otherwise find b. Well, this equation and this equation are the same, so we can make them equal, make the y's equal. So minus 2x plus 2b equals minus 2x plus 5 over 2b minus 4. Cancel the 2x, the minus 2x's. Take the 2b to the right, that'll leave me with a half b, and the 4 to the other side, and then times by 2, so b equals 8. And there we have it. Job done. Not too difficult, but quite long-winded, use of letters, and at the end of an exam, it's easy to see why a lot of candidates dropped marks or didn't even attempt this question. But there was some easy marks to be gained. Hopefully that'll help you out if you see it in future. Okay, question 8, quite late on in the paper. This is now on the October 23 paper. There's only 2 really difficult questions there, 8 and 10. And this is the first one. Now, this one proved harder than anticipated by the examiner. And in part, it's because of the use of calculator technology. You've got this sentence at the beginning. When you see this sentence, it's basically a non-calculator question. Obviously, you've got your calculator, you can use it, but you've got to show sufficient working out as if you solved it without your calculator. And approaching it without your calculator, just using it as backup, is the best way to go about it. So let's get into this question. We've got 2 curves, C1 and C2. Show that C1 and C2 meet at that point. Okay, so this point, if we look at this, it's only contains x, whereas obviously C1 and C2 contain y. So we need to eliminate the y's. So this one's already y equals, so we'll put this one inside of that one. So we're looking at, because we've got xy equals 15 over 2 minus 5x. So replacing the y with x cubed minus 7 over 2x minus 5 in that equation. Now multiplying through by x, we get x to the power 4 minus 7 over 2x squared minus 5x equals 15 over 2 minus 5x. Now the minus 5x's will cancel at that point. So we've got, if we multiply by 2, because there's no fractions in the question, so multiply by 2, so we get 2x to the power 4 minus 7x squared equals 15. 2x to the power 4 minus 7x squared minus 15 equals 0 as required. Okay, quite straightforward there, easy 2 marks. Now, given that C1 and C2 meet at the points P and Q, find using algebra the exact distance of P and of PQ. So part B, we're first going to solve this equation. Now it's x to the 4 and x squared, so it is like a quadratic. You can use a substitution like not y, because obviously y is in there, x, like let a equal x squared. So you've got 2a squared minus 7a minus 15 equals 0, and solve that and then resubstitute it back in. Or you can just leave it in terms of x squared. Okay, it's totally up to you. Now I'll do it with a substitution because I feel that the people looking at this question are the ones that maybe can't do it. So I'll use a substitution to help those. So we have 2a squared minus 7a minus 15 equals 0. So this is going to be 2a and a, and 15 is 1 and 15, 3 and 5. We've got to get to 7. So 10 take away 3 because it's going to be the 2 times. So we've got that scenario there. We've got to have minus 10 plus 3. So that's what we've got. Therefore 2a plus 3 equals 0. A minus 5 equals 0. A equals minus 3 over 2. A equals 5. Okay, so that's where I'm at so far. Now carrying on up here. A is x squared, so x squared equals minus 3 over 2, or x squared equals 5. This is impossible, the minus 3 over 2, so we've got x equals plus or minus root 5. So that's my x coordinate. Next I need to find my y coordinates. So for that I'm going to substitute into this one, I think. Or I could substitute it into this one and divide by x. So if I divided by x here, I'd have 15 over 2x minus 5. So I could substitute it into this, which would be a little bit easier, which is what I'm going to do. And that gives me minus 10 plus 3 root 5 over 2. And then if I do 15 over minus 2 root 5 minus 5. We get minus 10 plus 3 root 5 over 2. So just sorting these out, this is 3 root 5 over 2 minus 5, and this is minus 3 root 5 over 2 minus 5. Okay, so here we have our coordinates. So just imagine, PQ is some line PQ. We're going to use Pythagoras to solve it. So looking at the y's, we've got 3 root 5 over 2 minus 5, and 3 root 5 over 2 minus 3 root 5 over 2 minus 5. So the difference between those, so like this one, take away this one, so this, take away this, would be this minus minus this. So it's going to be, I'll do it in black, 3 root 5. And then when we look at the x ones, we've got a minus root 5 to a plus root 5. So that's going to have a distance of 2 root 5. So PQ is 3 root 5 squared plus 2 root 5 squared, which is the square root of 65, which will stay as that because it's an exact distance, and you just put it in your calculator, it won't simplify any further. So that's that one. It's worth quite a few marks. It's a bit awkward, especially, you know, with the coordinates, and towards the end I think it does help writing this out in the coordinates and finding the difference of the x and the difference of the y before substituting it in, rather than trying to put everything in one go into the square root. But that's just me personally. Let me know if you think the same, or if you would just do it a little bit differently. Right, let's have a look at question 10. Okay, question 10. So many candidates were able to score 2 marks on this question, although it was very rare for candidates to score the full 6 marks, with part C being missed out almost completely. So let's get into this question. We've got a cos graph, and it's y equals 3 cos x over n. The curve cuts at P at 270, state the value of n. So first things first, let's think of a normal cos graph. So cos graph will go something like this. This is 360, 270, 180, 90, and 0. And that's got a period of 360 degrees, and obviously crosses at 90 and 270 there. Now in this graph, the one we've got here, P, the point it crosses, is at 270. So the first point that this is crossing here is at 270, and it should cross at 90. So that's 3 times as far. So this is y equals 3 cos x over 3. Because when you're dealing with like transformations, inside the brackets deals in the x direction, and you always do the opposite. So the 3 times as far as in the angle, 3 times the size, would be divided by 3. If this had been 30 degrees, then it would have been a 3x. Okay, it's because that this is, instead of seeing, you know, one complete cycle between 0 and 360, we'd have a third of a cycle between 0 and 360, which is like this one. So it's a third of the cycle. So the whole cycle itself would be 1080. So 360 multiplied by 3. Okay, so we've got part A done now. So n equals 3. And remember to use 3 and not 1/3 there, because in terms of the equation they're giving us, n is on the bottom. Part 2, the period is 1080 there, because this graph is going to take 3 times as long to complete one full period. So that's how part A done. Now for part B, we've got to work out the coordinates of Q. So part B, coordinates of Q, well, there's obviously going to be a -3 for the y coordinates, because it's got 3 in front, which means that instead of between -1 and 1, it's between -3 and 3. So that's going to be -3, but we need to find the degrees, the x value. So if I look here, we've got 1 and 2. So it's on the second full period. So after the 360, we go down again and up. So that will take us to 720. So if I think about it, it's every 90 degrees in this case. So 360 is at the top, so this hits there at 450. It hits there at 540. Hits there at 630, and it hits there at 720. So it's 360, 450, 540, 630, 720. And this is where Q is. Yeah, 1, and then on the bottom of my second one. So 540, and of course we said we're multiplying by 3. So 540 times 3 is 1620, so it's 1620 and -3. Okay, so all I'm doing is breaking it down logically and comparing what the original graph will look like to what the transformation is. Now part C, y equals 2 sine x plus k, and the points R and the points S both lie on that equation, that curve. So if I substitute R in, we've got y is 12/5, and that's 2 sine A plus k. And I look at the second one, and y is -3/5, and that equals 2 sine A plus k. Now I have spoken to this during this video, but knowing that sine of minus an angle is minus sine of positive the angle, and that's important to be able to do. So minus 2 sine A plus k. So what I can do now is eliminate 2 sine A and find out what k is. So if I take this first equation here, or I could take this one, it doesn't really matter. I'll take this first one. 2 sine A equals 12/5 minus k, and substitute it into here. So minus 3/5 equals minus 12/5 minus k plus k. So minus 3/5 equals minus 12/5 plus k plus k. So that's 2k, and that equals 12/5 minus 3/5. So 2k equals, so 12 minus 6, so it's 9 over 5. So k equals 9 over 10. And that is all. Of course you could eliminate k, but then you have to find the angle and then substitute back in, because you don't need to find a, you just need to find k. And that comes the end of the video. Again, if you're new, please subscribe. If you enjoyed the video, like. Any questions, comment down below. And again, if you like my content and you wish to help me out a little bit, please consider becoming a member, if even only just for a month. Anyway, see you in the next one.